Hey everyone! Have you ever looked up at the night sky and wondered, what is the shape of the universe? Is it a big ball, a flat pancake, or something even cooler? Well, buckle up, because today we're going on an epic journey to explore the shape of everything. First, let's imagine the universe as a giant playground. Picture children running around, laughing, and playing games. Now, replace those children with planets, stars, and galaxies. Each celestial body is like a child, full of energy and constantly moving. The playground is vast, almost infinite, with endless possibilities for exploration and discovery. In this playground, we have planets, stars, galaxies, and lots of empty space. The planets are like the swings, moving back and forth in their orbits. The stars are like the bright lights that guide us, and the galaxies are like different sections of the playground, each with its own unique features and attractions. The empty space is like the open areas where anything can happen. But what's holding it all together? Just like a playground has rules and structures to keep everything in order, the universe has forces that maintain its balance. Gravity is the invisible hand that keeps the planets in their orbits and the galaxies in their clusters. Without gravity, the playground would be chaotic, with celestial bodies drifting aimlessly. Is there a wall at the edge of the universe? Or does it go on forever? Imagine running to the edge of the playground and finding a fence, or maybe there's no fence at all, just an endless field. Scientists are still trying to understand whether the universe has boundaries or if it extends infinitely in all directions. To answer this, scientists need to figure out its shape. Is the universe flat like a sheet of paper, curved like a sphere, or something else entirely? By studying the cosmic microwave background radiation and the distribution of galaxies, scientists hope to uncover the true shape of our cosmic playground. This knowledge will help us understand the ultimate fate of the universe and our place within it. So, how do we figure out the shape of the universe? Well, scientists look at three main possibilities. They call them flat, open, and closed. Don't worry, it's not as tricky as it sounds. Let's start with flat. The concept of a flat universe is quite fascinating and easy to visualize. Imagine a vast, endless sheet of paper. This paper extends infinitely in all directions, never curving or bending. It's a simple yet profound idea that has intrigued scientists and astronomers for decades. If the universe is flat, it's like a giant piece of paper. This means that the geometry of space is Euclidean, which is the kind of geometry we learn in school. In a flat universe, the angles of a triangle add up to 180 degrees, and parallel lines never meet. This is the most straightforward and intuitive way to think about the cosmos. It stretches out forever in every direction, and light travels in straight lines. This has significant implications for how we understand the movement of light and the propagation of signals across the universe. In a flat universe, light doesn't bend or curve due to the shape of space itself, making it easier to predict and understand its path. Imagine walking on a flat road that never ends. Pretty cool, right? This endless journey symbolizes the infinite nature of a flat universe. No matter how far you travel, you would never encounter a boundary or an edge. This concept challenges our everyday experiences and stretches our imagination to grasp the true scale of the cosmos. Next, we have the open universe. This type of universe is a bit more complex and intriguing. Unlike the flat universe, an open universe has a unique curvature that affects how objects move and interact within it. This one is shaped like a saddle. The saddle shape means that the universe curves outward, creating a hyperbolic geometry. In this type of universe, the angles of a triangle add up to less than 180 degrees, and parallel lines eventually diverge. It curves outward like the shape of a Pringles chip. This curvature has profound effects on the behavior of light and matter. For instance, light beams that start off parallel will eventually diverge, and the paths of moving objects will be altered by the curvature of space. If you tried to draw a big circle here, it would look stretched and weird. This distortion is a direct result of the universe's curvature. Objects and shapes that we take for granted in our everyday flat world would appear very different in an open universe. This can make visualizing and understanding such a universe quite challenging. Finally, we have the closed universe. This type of universe is perhaps the most mind-bending of all. It introduces the concept of a finite yet unbounded space, which can be difficult to wrap our heads around. This one is like a big ball or a globe. In a closed universe, space curves back on itself, creating a finite volume. This means that if you travel far enough in one direction, you will eventually return to your starting point, much like circumnavigating the Earth. If you traveled in a straight line, you'd eventually end up back where you started, like walking around Earth. This concept is both fascinating and perplexing. It suggests that the universe has no edges or boundaries, yet it is not infinite. Understanding a closed universe requires us to rethink our notions of space and distance. Each of these models, flat, open, and closed, offers a unique perspective on the nature of our universe. They help scientists develop theories about the origin, evolution, and ultimate fate of the cosmos. By studying the shape and geometry of the universe, we can gain deeper insights into the fundamental laws that govern everything around us. Modern astronomy and cosmology use advanced tools and techniques to measure the curvature of the universe. Observations of the cosmic microwave background radiation, the distribution of galaxies, and the behavior of distant supernovae all contribute to our understanding of the universe's shape. These observations have led to the current consensus that our universe is very close to flat, but with a slight curvature that is still being studied. The quest to determine the exact shape of the universe continues to drive scientific research and exploration. Understanding the shape of the universe is not just an academic exercise. It has practical implications for our understanding of physics, cosmology, and the ultimate fate of everything. Whether the universe is flat, open, or closed, each model provides valuable insights that help us piece together the grand puzzle of existence. As we continue to explore and learn, we move closer to answering some of the most profound questions about our universe. The journey of discovery is ongoing, and each new piece of information brings us one step closer to understanding the true nature of the cosmos. So, whether you imagine the universe as a flat expanse, a curved saddle, or a spherical globe, remember that each model represents a different way of understanding the vast and mysterious universe we call home. Okay, but how do scientists figure this out? They don't just guess. They use a combination of observations, theories, and advanced technology to understand the universe's shape. It's a complex process that involves many steps and a lot of data. One of the key tools they use is the study of something called the cosmic microwave background radiation. This radiation is like a snapshot of the universe when it was just 380,000 years old, which is incredibly young in cosmic terms. The cosmic microwave background radiation is essentially the leftover heat from the Big Bang, the colossal explosion that created the universe around 13.8 billion years ago. This heat has been traveling through space ever since, carrying with it vital clues about the early universe. By examining how this heat is distributed across the sky, scientists can infer a lot about the shape and structure of the universe. They look for tiny variations in temperature, which can tell them whether the universe is flat, open, or closed. But that's not all. Scientists also use supercomputers to simulate different shapes and compare them with the actual data. These simulations help them understand how different shapes would affect the cosmic microwave background radiation. Telescopes, both on Earth and in space, play a crucial role too. Instruments like the Hubble Space Telescope provide detailed images of distant galaxies and stars, helping scientists piece together the puzzle of the universe's shape. It's a collaborative effort involving astronomers, physicists, and mathematicians from around the world. They share their findings, debate theories, and work together to refine our understanding of the cosmos. So, while it might seem like an impossible task, the combined efforts of these brilliant minds bring us closer to understanding the true shape of our universe. It's a fascinating journey of discovery that continues to evolve with each new piece of data. Here's the crazy part. The data tells us that the universe is really close to being flat. But don't picture it like a piece of paper. Even if it's flat, it still has some twists and turns because of gravity and all the stuff inside it. Now here's a mind-blowing idea. The universe doesn't have edges. If it's flat, open, or closed, it either goes on forever or loops back on itself. So no matter how far you travel, you'll never find a wall saying the end. Scientists are still exploring this mystery. New telescopes and experiments might give us even better answers in the future. But for now, isn't it amazing to think we're part of something so huge and incredible? So what do you think? Is the universe flat, open, or closed? Let me know your thoughts in the comments. And don't forget to like, share, and subscribe for more cosmic adventures. Until next time, keep wondering and keep exploring. Subscribe for more space fun.